Greetings everybody and welcome back to another exam video. Today we're taking a look at the 2023 Specialist Maths Exam 1. I literally just got this copy off of my Discord server like a few minutes ago, so I pretty much haven't read through any questions. Well, I guess I have now. I've seen the first 3 questions or so. But yeah, I know there's going to be a proof question. So hopefully I managed to do that one, because as a pure math student it will be a little bit embarrassing if I can't get that one, because you're pretty much writing proofs all day. But yeah, anyways, let's just jump straight into the first question. I'm also very rusty at Spech, I think, because I haven't tutored Spech in like 2 years, so I don't know how much I forgot or remember whatsoever. But yeah, let's just jump straight into it. So we have function, rational function, and we want to show that the rule for the function can be written in this nice form over here. So that's just long division, nice 1 marker. So we have x squared plus x minus 6 divided by x minus 1. How do you do long division? You divide the thing somehow. So you have x up over here, then you multiply down, so x squared minus x. You subtract it, and you get x plus negative x, which is just 2x minus 6. Divide again, so that's going to be plus 2. And then you have a 2x down here, and then a negative 2, and then you do the subtraction again, and then you get 6 minus negative 2, which is negative 4, which is your remainder. So therefore, f of x is just quotient, which is x plus 2, plus remainder, which is negative 4, over divisor, x minus 1. Okay, part B, sketch the graph of f, labeling asymptotes with their equations. So, let's see. We know we're going to get an asymptote at x equals 1 from this principal part of the Laurent series, and we're going to get another asymptote, which is just the analytic part of this Laurent series. So let's put in x equals 1. So we'll do something like this. That's a slightly wonky line. Use a ruler. I can't be stuffed using a ruler. So x equals 1. Actually, I probably should use a ruler. And then we have y equals x plus 2. So that's going to come up something like this over here. Something like that will do. So that's y equals x plus 2. So we'll do that. So, yeah, we just have to put the graph in now. So this is y equals x plus 2. I probably they're not telling us to find intercepts though, but I'll probably find them anyways, just so I have some guide as to how to put my function through. So what's the y-intercept? Well, it's going to be f of 0, but what's f of 0 going to be? F of 0 is just going to be 0 plus 2, which is 2, minus 4, over 0 minus negative 1, which is, negative 1, so that's just going to be 6. Okay, so we have vertical intercept at 6, and the x-intercept. We can just use the original function, I think. Just set the numerator equal to 0. Because we don't want the denominator equal to 0, because that's the asymptote. So just setting the numerator equal to 0, that's x squared plus x minus 6. So we have x squared minus x plus 6. Was it minus x plus 6? It was, no, plus x minus 6. Plus x minus 6. So this equals 0. So factoring, that gives x plus 3, and then x minus 2 equals 0. So you're going to get x equals negative 3. Or x equals 2. So that's pretty much everything you need there. I'll try to do a rough graph. You guys could probably do a better job than me, because it's kind of hard doing it on the drawing pad. Yeah, something like that. That's good enough. Alright, sketch the graph of f, labeling asymptotes, blub, blub, blub. That should be all. So we've got a nice 4 marks in under 4 minutes on the recording. Perfect. So, question 2. Complex number. Okay, we cube something. B is positive. Find B given that argz equals negative pi and 2. Okay. So what I'm thinking, we have, negative pi on 2 equals the argument of z, but that's just the argument. What is z? It's just b minus I, but we cubed this thing. Okay. So what does an argument of negative pi and 2 mean? Well, let's draw out the argens plane, whatever it's called. That means we want our number to lie on this array. Okay. Now we know, let's see, we know what happens to a complex number when we cube it. It rotates, or it multiplies the angle by 3. Right, so we want our complex number to end up on this line somehow. So let's think about b minus I. What's b minus I? Well, b's a positive real number, and then we have a minus I. So our complex number is going to live on this line here. Actually, only the positive side, because b's positive, so it's gonna live on this line right over here. So what we want to do, so here's some complex number. Yeah, we'll call this b minus I. It's gonna live on this line somehow, and we can think about it as a vector, like that. We want to have the angle here, so the angle should be something that when you cube it, when you multiply the angle by 3, it lands onto this red line, because we're cubing. So that means this angle needs to be pi 6, or technically negative pi 6. So let's find that line, or that value of b. That shouldn't be too bad because it's just Pythagoras. So how does Pythagoras work? It's what's the tan formula? It's tangents. It's opposite over adjacent, I think, equals tangent of pi on 6. Okay. Tangent of pi on 6 is root 3 on 3. So opposite over adjacent. What's the opposite side? It's 1. What's the adjacent side? It is b, I think. Yes, it's b. So what does that mean? It means b is equal to root 3. Yeah, that should work. So b is root 3. Is that all? Find b. Are there multiple solutions for b? I don't think so. Because b is positive. That should be the only number that works there. Did I do something wrong? That doesn't feel like 3 marks. Maybe I'll just check it. So the complex number would be root 3 minus I. And you can write this in polar form. So it's r cis, which I don't like cis notation. The angle. So what's the modulus of this thing? It's the square root of real parts squared, which is 3, plus imaginary parts squared, which is 1. So that's just going to be square root of 4, which is 2. And then we have the cis over here of negative pi on 6. Yeah. So if you cube this thing, cubed, that's just going to be 8 cis negative pi on 2. Hopefully that's right. That doesn't feel like 3 marks, but yeah. Anyways, question 3, particle moves along a straight line. When we have, yeah, I think I'm kind of screwed for this one. I know there's a formula with like acceleration v and x, and I completely forgot what that formula is because I haven't used it. I haven't seen it in like 3 years or 2 years. So we have velocity. This is the velocity in terms of x. So we have v of x. And we want to find, let's not write it. We want to find the a. We want to find a of x when x equals 2. For x equals 2. So there's a formula. I'm going to pause the recording. I'm going to try to find that formula. That might be cheating though. I don't know because I just completely forgot what that formula is. So I'm going to pause and come back. Okay, so I got some formulas. I managed to find, yeah, the notes I wrote for one of my tutoring students back in 2021 when I was tutoring Splash. And I think this is what we need to use here. So what I have, we have v in terms of x. So we want to use, I think it's this formula. So the acceleration is v times dv on dx. So using that, we have a equals v dv dx. So that's just going to be 3x plus 2 over 2x minus 1 times dv on dx. So what's dv on dx? Well, we just gotta, yeah, somehow work with this. Let's just quotient rule because I don't know. So quotient rule, how does that work? It's 2x minus 1 but squared. And on the top you do v, which is 2x minus 1 times u dash, which is just going to be 3. And then you do minus u, which is the 3x plus 2 times v dash, which is 2. Okay, so you do a of x equals 2 to get the acceleration. I think that's all. So what happens if you plug in x equals 2? Well, you're going to get, that's 2 times 2, which is 4, minus 1, which is 3. So that's just going to be 9, minus, over here we have 3 times 2, which is 6, Right, 3 times 2 is 6, plus 2 is 8, times 2 is 16, so 9 minus 16, divided by, what happens if you plug 2 into here, you're going to get 2 times 2, which is 4 minus 1, which is 3, square that, and that's going to be 9. So that's going to be, what's 9 minus 16? Is that negative 7? Negative 7 or 9? Meters per second squared. I'll take that as the answer. I'd probably be wrong though. Maybe I applied that formula incorrectly. Find the value that the velocity of the particle approaches as x becomes very large. Find the value that the velocity of the particle approaches as x becomes very large. So we just take a look at this thing over here, this expression, and maybe we need to rewrite it in like the similar form for question 1, like in this form over here with the hyperbola part. So we can take a look at the limits as x approaches infinity. So how do we do that? Well, let's just do long division. So 3x, actually you don't need to do that because as x becomes very large, these constants over here, they're not going to dominate. The terms that are dominating are 3 and 2. If you know L'Hopital's rule or something like that, you could probably use the same logic. It's just going to become 3 on 2. 3 on 2. A nice way to see that is you can rewrite v equals 3 plus 2 on x over 2 minus 1 on x. So you just divide everything through by x. As x becomes big, these parts over here vanish. So this goes to 0, this goes to 0, leaving you with 3 on 2. Yeah. So that's, meters per second. Take that as the answer. Okay, so that's 3 marks plus 3 marks, that's 6 plus 4 marks, that's 10 marks in a little under 12 minutes, so looking alright so far. Consider the relation, so arcsine. Do they ever use arcsine? Because usually they use sine inverse, don't they? I don't know. Use implicit differentiation. Hopefully I remember how to use implicit differentiation, because I haven't implicit diffed in like 2 years. So, implicit differentiation to find the dy and dx at this point. How do you do implicit differentiation? I think it's on the left hand side, that's just going to be product rule. So how does that work? It's v, so the arcsine of y squared, times u dash, which is just going to be 1, plus u, which is just x, times v dash. What is v dash going to be? It's going to be, what's the formula for this? I forgot all the special formula. It's 1 over 1 minus y to the 4 in this case, because of the y squared. So we square the y squared. I think that's the arcsine formula. Is it? Let me pause the recording and I'll search up the arcsine formula on Google. Okay, good news, I got it right. So it's this thing. And then because of chain rule, we need to multiply by 2y. So we have a 2y at the top here. So we've got the 2y. And then because y is a function of x, we need to multiply by dy and dx. I'm pretty sure that's how implicit differentiation works. And then this is equal to 0, because derivative of pi is just 0. It's a constant. So let's work through this. So y is just going to be, let's plug in this point here. We're going to get the arcsine. What's y squared? It's just going to be 1/2. So arcsine of 1/2 plus x, which is 6. We have 2 times 1 over root 2, which is going to be square root of 2 over here. And we're going to have, so 2, yes, that's square root of 2. And then we have the square root of 1 minus, what's y to the 4? Well, y squared is 1/2. So y to the 4 would just be 1/4. So we have square root of 3/4 in there. 3/4, and then we have dy dx, and that's equal to 0. Question is, what on earth is arcsine of a half? That's just the angle that gives you the sine of that angle equals to a half, which I'm pretty sure is pi and 6. So pi and 6 is, we have 6 square root of 2 divided by square root of 3 on 2. Okay, we can bring that 2 up, so that's just going to be 12 at the top there. So 12 root 2 on root 3 dy dx equals 0. So, rearranging, we're going to get dy dx and that's equal to negative pi and 6, and then we multiply this factor over, which is, so we get to a negative pi and 6, okay, and then we multiply the reciprocal of this guy, which is root 3 over 12 root 2. And what does that simplify to? It simplifies to negative, can we cancel anything? So 6, 12 is 72, probably. And we can rationalize the denominator here, so let's multiply by root 2 on root 2, and this will be a 2 here. Okay, and we have a root 6 at the top, so negative pi square root of 6 divided by 6 times 12 is 72, times 2 is 144. Yeah, I'll go with that as the answer. It's in the correct form though. Hopefully I did implicit diff correctly. Okay, evaluate this integral. I just want to do integration by parts here. Do they teach you integration by parts in Spec? Wasn't that new in the study design? I don't even know what's new in the study design. So I'm just going to do my usual DI method. I actually haven't done integration by parts in so long, so hopefully I don't screw this up. So it's x squared 2x and then 2. No, you do it the other way around. So you actually want to differentiate log base e of x, and that gives you 1 over x. And then for the integral, you want to do x squared, and then you have 1/3 x cubed plus minus. Okay. So I'm pretty sure the way it works is the diagonal over here is the answer, what you just write down. So 1/3 x cubed times log base e of x. And then you do minus the product over here as an integral. So this evaluates from 1 to 2. And then you minus the integral from 1 to 2 of the product down here, which is just going to be 1/3. And then you have x squared dx. Right, that should be it. Okay, so let's plug things in. So plugging 1 into the logarithm gives you 0, so we can ignore 1. So this is going to give you just plug 2 in, so that's just going to be 1/3 times 8 times log base e of 2 minus the integral of this guy, which hopefully isn't too bad to evaluate. It's just going to be, we have 1 over 9 because we have an extra 1/3 from this power rule, and then we have x cubed, and then we go from 1 to 2. Right, that's going to be 8 on 3 log base e of 2 minus 1/9, and then we have 8 minus 1. 8 minus 1 is 7, I think. So in the variant, we get 8 over 3 log base e of 2 minus 7 on 9. Hopefully that's the right answer. I'll check it later on the CAS. Okay, probability looks like. Did they change anything for probability? I don't know. We'll find out if there's anything interesting going on. So Josie travels from home to work in the city. She drives a car to a train station. Once then rides on a train to the city. The time is XC taking the drive to the station. So let's draw a picture. So here's house, and then here's train station, which I'll draw a train. I don't know how to draw a train. Actually, I'll just draw. How do you draw that? Those choo-choo trains or something? Those steam trains, something like that. I don't know. So XC is the time it takes to drive to the station, is normally distributed with a mean of 20, standard deviation of 6. So XC, normal, 20,6 squared. Standard deviation of 6. The waiting time for the train is normally distributed, so now she has to wait here. So XW is normally distributed with a mean of 8 and a standard deviation of root 3. So root 3 squared. So the train arrives, let's do that. The time XT it takes to ride the train to the city is also normally distributed, so city, so I'll draw buildings, so there's so many random variables here. So this is XT, is normally distributed with a mean of 12 and a standard deviation of 5. So 12, 5 squared. The three times are independent of each other. That's great. Find the mean and standard deviation of the total time in minutes it takes for Josie to travel to and from the city. Okay. So the mean of, let's just write it as this: E of xc plus xw plus xt is just the separate means. So E of xc plus E of xw plus E of xt. So you use the linearity of the expected value operator. And that's just going to be, well, what's E of xc? It was 20, and then plus 8, and then plus 12. So that's just going to be 40. Standard deviation, so we want to use the variance. So the variance of xc plus xw plus xt. The variance is also kind of linear, not really. So this is just going to be the variance of xc, and then plus the variance of xw plus the variance of xt. What is that? The variance of xc is just going to be 36, plus the variance of xw is going to be 3, plus the variance of xt is going to be 25. Okay, so what's that going to be? 36 plus 3 is 39. What's 39 plus 25? Well, 40 plus 25 is 65, so one less than that is 64. So that means that standard deviation of the sum over here is going to be equal to 8. So 8 minutes. So those are our answers. That's it. So Josie's waiting time for the train on each workday is independent of her waiting time for a train on any other workday, so binomial probably. The probability that for 12 randomly selected workdays, Josie's average waiting time is between 7:45 minutes, 8 minutes and 30 seconds is equivalent to this thing over here. Well, A and B are real numbers. Find A and B. Let me think. The probability that for 12 randomly chosen days, her waiting time is between these two values. So this is not binomial. I was waffling. Is equivalent to this. Okay. I forgot how to do these questions. That's not good. So we have 12 randomly chosen days. Average waiting time. So this is average waiting time. Okay, so we have to use, what was the formula? So if we take a look at x bar over here, which is the average, this is going to be normally distributed. So this is waiting time. Waiting time for a train on each day of work. What's the waiting time for a train? The waiting time for a train is, mean of 8, standard deviation of root 3. So it's going to be normally distributed with, we have root 3 divided by just 12, because that's the sample size, I guess. And then this is squared. Okay. And what are we doing over here? Well, this is probability. Let's actually try to simplify the standard deviation. I don't know if we can though. Let's just leave it like that. So we have the probability that Josie's average waiting time is between 7 minutes 45. So this is 7.75 is less than x bar is less than 8 minutes and 30 seconds. So this is 8.5. So we just need to standardize here. So this is equal to the probability. We have negative 0.25 divided by the standard deviation, which is root 3 on 12, less than z is less than, we have 0.5 divided by standard deviation, which is root 3 over 12. Okay. And let's simplify. So this is the probability. And we have the root 3 over here. So let's bring the 12 up. What happens if you have 12 times 0.25? Well, 0.25 is a quarter. So you're just going to be left with 3. So negative 3 over root 3 less than z is less than. What happens if you bring the 12 up? You're going to get 12 times 0.5, which is 6 over root 3. Let's try to simplify. So we can just probably read off our A and B values right away. So we have A is equal to negative square root of 3, and B is equal to, we have, let's rationalize, so we rewrite this as root 3 on 3. So root 3 times 3 is 3. So this just leaves us with 2 on the bottom, 3, and then 6 divided by 3 is 2. So this is going to be 2 root 3. I will take that as my answer. Okay. So, question 7. Curve defined by something, parametric equations. This is rotated about the x-axis to form an open hollow surface of revolution. Okay. Find the surface area of the surface of revolution. Give your answers in this form. Okay, so we have to remember how to get the surface of revolution thing. I don't know if I remember the exact formula. I think it was to do the integral from you have a t equals 0 to t equals 2, and then you have something like the square roots. Was it square roots? No, I'm thinking of the arc length formula. Yucks, this is rotated about the x-axis. So how do you do that? So x equals t squared, and then you have this thing. So you have y. Y is just moving. This is just square root of t, so it's basically linear. And then x is it's some quadratic. So I'm gonna guess it's some kind of bowl shape, like so. You have -1 as well, something like that. And then t goes from 0 to 2. So you're gonna get some kinds of surface that looks like this. Okay, I forgot how to use the I don't know if I ever used that formula. So it's going to be the square. I know there's going to be a square root, a 2 pi times. So it's 2 pi times the y value, I think. So 2 pi times it was root 3t. So 2 pi times the y. So that 2 pi times the y gives you. So first of all, y is the radius. You can think about it that way. Y is just the radius. And then you do 2 pi times that to get the circumference. And then you need to multiply by some kinds of square root, which I believe was just dx on dt, but squared, plus dy on dt, but squared. If I get this wrong, I'm probably going to remake this video because I don't have the formulas memorized at the top of my head. I'm just trying to work this out intuitively. So this is 2 pi. We have, 2 pi root 3 actually. So 2 root 3 pi. Integral from 0 to 2. We have t, and this just calculates the the square roots there. So dx over dt squared. What is that going to be? That's just going to be, dx on dt is going to be t on 2. Right, should just be in t on 2. So we have t squared on 4. And then plus dy on dt, what's that going to be? It's just going to be root 3, but just that. Okay, dt. Is that right? So dy on dt is just root 3. So you square that becomes 3. And then dx on dt looks fine to me. Okay, so what can we do now? Let's just do a substitution. So we're going to let u be equal to t squared on 4 plus 3. Okay, so what's du going to be? Du is going to be t on 2 plus 3. Is that right? Why am I getting t on 2 again? So t on 2, if you square that, you get t squared on 4. Okay, that should be fine. So t on 2 plus 3. No, it's not plus 3 because the derivative of the thing is, I'm silly. And then dt. Clearly I'm so rusty with spec. It's not good. Okay, so how does this work now? So we want a t on 2, so I'm going to divide by 2 and I'm going to multiply by 2 to compensate at the front. So we're going to get a 4 here. I'll write that as 2 times 2 just to be clear. Right, so I'm just introducing this 2 and this 2 here. So that means we have so this part over here, the green bit I'm highlighting, t on 2 dt, that's our du. And then let's figure out the bounds as well. So what's u of 0? U of 0 is 3. And u of 2 is just going to be 4. Right, because 2 squared is 4. Divided by 4 is 1, and then plus 3. Okay, so this is equal to, we have 4 root 3 pi. Integral from 3 to 4 of, we have our du sorted, and then we're just left with the square root of u. And integrating this, what do we get? We get 4 square root of 3 pi in square brackets, integral of root u, I think it's 2/3, times u to the 3 halves, 3 to 4, right? And then this is equal to, let's see, we have 8 on 3, square root of 3 pi. I'll write that nicer. So this is 8 square root of 3 times pi over 3, right? And then we have this part over here. So what's 4 raised to the 3 halves? And then what's 3 raised to the 3 halves? Right, so that's just going to be, 8 square root of 3 pi over 3. And then we have 4, you take the square root of 4, which is 2, and then you cube it, which is 8. So we have an 8 over here minus 3. This is just basically root 3 times root 3 times root 3. Right, that's just going to be 3 root 3. Oops. So we have 3 root 3. You could probably simplify this. Did they want it in a particular form? They wanted a pi at the very front, and they want us to multiply everything in. So let's do that. So this is going to be equal to pi. We bring that to the front, and we multiply everything in. So that's just going to be 64 square root of 3 over 3. All right. So 64 root 3 and 3. And then minus, we have this thing times the rest. So that's just going to be 24. Square root of 3 times square root of 3. That's 3, which is good. And then divided by 3, perfect. So we can forget about all the 3's there. Right? No, we have root 3. We have another root 3. So that's 3. That cancels with this 3. But we still have the 3 over here. So that should be 24. Okay. So minus 24. Is that in the correct form that they want? Hopefully. So A root B and C, yeah. Yeah, it looks right. Perfect. So hopefully the numbers are right. Question 8. Where's the proof question, by the way? I don't see a proof question. A function... this is the proof question. Induction. Okay, that's interesting. So a function has this rule. Use mathematical induction to prove that this thing, for n is a positive integer, when fn of x represents the nth derivative of x. Okay, so base case. So how does induction work? You'd start with the base case, which is... Actually, you need to define the proposition, or... Yeah, the proposition. So we're going to let P of n be the proposition that's, fn of x equals the stuff over here, which I'm not going to bother and write down. So I'm just going to highlight that, and I'm going to say that's the stuff over there. Okay, so you start off with base case. What's the base case? Base case is n equals 1 because we have positive integers over here. So what's n equals 1? You check that. So you just need to calculate f prime of x, or f1 of x, I guess. So f1 of x is equal to, you do chain rule, not chain rule, product rule, and you do a bit of chain rule as well. So that's going to be, let's call this u, let's call this v over here. So you do vu dash, which is e to the 2x, plus uv dash, which is 2x e to the 2x. Alright, so u and then v dash. Right, so does that fit our P1 proposition? So 2 to the n. So here n is equal to 1. Right, so let's try to write it in that form. So this is exactly, we need a factor in e to the 2x. So if we do that, let's factor it out to the back. So this is e to the 2x. And then let's write this 2x first. So this is a 2, we write this as 2 raised to the 1. Right, and then we have an x, and then we have plus n, which is plus 1 in this case, and then we have 2 to the n minus 1. So we can write this as 2 raised to the n minus 1, which is 1 minus 1, and this whole part over here, that's just 1, because 2 to raise to the 0 is just 1, and then you have, this is 1. Okay, so looking good so far. So because we can write it in this form over here, so therefore P of 1 is true. Okay, so we next do the induction step. So induction. So what you do is you let k be some positive integer, k greater than 1. Actually, k technically could be, it doesn't matter. So k is just a positive integer. Okay, and you basically assume that p of k is true. So assume p of k is true. Then you want to show that p of k plus 1 is true. Right, so how can we do this? Well, because p of k is true, we can basically just write down the formula that they're given. So fk of x, that's just equal to 2 raised to the k times x, and then plus, we have k 2 to the k minus 1 times e to the 2x. So we write this down. And then now you want to show that p of k plus 1 is true. Now, how do you get to p of k plus 1? You just differentiate this guy. So f of k plus 1 of x. Let's just do the derivative over here. So that's not too bad to do. It's just, once again, bit of chain rule and product rule. So let's think about this. So I'm going to differentiate this part first. So how do you differentiate that? That's just going to be 2 to the k. And this thing over here is just a constant. So yeah, just 2 to the k times e to the 2x. And then you have plus, you keep this thing over here. Right, you keep it, and then you differentiate the e to the 2x. So what happens if you keep it? It's just 2 to the k, x plus k, 2 to the k minus 1. And then you differentiate the other guy, which is, that's just going to give you 2 and then e to the 2x. I'm going to put the 2 out over here. And then we have e to the 2x. Okay. And now I guess we can just distribute everything. So we can factor e to the 2x to the very back as well. So e to the 2x. And then we're left with 2 to the k. And then we have a plus. I'm going to distribute the 2 in over here. So this is going to be 2 to the k plus 1 times x. And then plus k times 2 to the k minus 1. Right? So let's see if we can simplify this. We have 2 to the k. We have k2 to the k. Oh, actually, this is just 2 to the k because I multiplied the 2 in as well. Right, so this is 2 to the k. Okay, so 2 to the k and then k lots of 2 to the k's. That's just going to give you, so we have 2k plus 1 and then plus k plus 1, lots of 2 to the k, e to the 2x. Does that match our proposition? Seems like it does. Because what you can do now is you can rewrite, if you want to be extra clear, this is 2 to the k plus 1, right? And then we have plus k plus 1. And then we have e to the k plus 1. But then we subtract 1, which matches the form that we want. So e to the 2x. Right, so we have the k plus 1s over here. I'll change this to green brackets as well. So, because we can write it in this form, it holds that, we basically have p of k plus 1 sorted. Let me just check that. So there's 2 to the n. So n is k plus 1 in this case. And then we have k plus 1. That should work. So therefore, I don't know how VCAA wants you to write these induction proofs. Usually what I just do is I just say p of k plus 1 is true. And then you kind of just finish off. This is how they teach you the induction proofs in uni, by the way. And then you just wrap up with the statement. So therefore, it's something like by principle of mathematical induction, POMI, P of n is true for all n in positive integers. And I believe that should be it there. Not too bad. It might be a bit tricky if you're not used to these proofs, but I don't find that too bad. It's pretty systematic. You just gotta redo the algebra a little bit over here just to get it into the form you want. Was there anything else to that question? Question 8: a function has the rule. Represents. It's fine. Okay. Maybe you need to put an extra statement at the bottom. I don't know. I'll just leave it at that. All right, 2 questions to go. Right, it's 40 minutes. So hopefully, we have 6 marks plus how many marks is the next one? Plus 6 marks. So 12 marks. We need to do 12 marks in 40 minutes. Let's try to do that. So a plane contains these points. The plane has a y-intercept of 2 at the point D. Write down the coordinates of the point D. As a y-axis, what? A plane contains the points where A is a real constant. The plane has a y-intercept of 2 at the points D. Oh, D is the y-intercept. Okay. Write down the coordinates of D. 0, 2, 0. Is that it? Y coordinate of 2 at the point D. Yeah, that's it. Show that AB is this and this respectively. A, B, and AD. So what's AB? AB is just OB minus OA. What's OB? I'll write it as a column vector because I don't want to write it out in these components over here. So OB is just -1, -2, 4, minus OA, which is 1, 3, -2. And that's just going to be -1, so this is -2. And then we have -5, and then we have 6, right? So if you want to write it out, it's 2i hats minus 5j hats plus 6k hats. And we do the same thing for AD as well. So what's AD? AD is just going to be OD minus OA. What's OD? It's 0, 2, 0 minus OA, which is 1, 3, -2. Yeah, so that's just going to be -1. 2 minus 3 is -1. 0 minus -2 is 2. So yeah, we get minus I hats minus j hats and then plus 2k hats. Okay. C, find the equation, hence find the equation of the plane in Cartesian form. So we have two vectors that line the plane because these points are in the plane, and we want to find the Cartesian equation. So let's see if I remember how to do this, because I've done these things at uni and I coded the CAS programs for these, so I should know how to do it. So you need to do AB plus cross AD to get the normal vector. So how do you do this? IJK, and then you do -2, -5, and then 6, and then you have -1, -1, 2. Okay, so let's just do the determinants thing. So that's just going to be, we have -5, 2, so that's -10. -10 plus 6. What's -10 plus 6? That's just going to be -4. So we have -4i. And then you do the j now. So you do -2 times 2, which is -4. So you have -4, and then you have a plus 6 over here. What's -4 plus 6? It's 2. But because this is the j, you do the negative of that, because it's 2. So you do -2 actually. So -2j. And then k, you do negative, so this is 2, and then you subtract off 5. So what's 2 minus 5? 2 minus 5 is -3. So yeah, just -3k. So these are the, we have these over here. This is the normal vector. And now, so you're going to get an equation that looks like, what was it? It was going to be minus 4x minus 2y minus 3z. And now I forgot how to get the constants. There's probably a way to do it, a nice fast way, which I completely forgot how to do. I think you just got to sub in one of the points here. So let's just plug in 1, 3, -2. Or actually, let's plug in 0, 2, 0, right? Because that's simple. So if we plug in 0, 2, 0, you're going to get, this is 0, this is 0, and you're going to get -4. So this should be -4, right? Because this equation should be true if we plug in the coordinate of D, which is 0, 2, 0. If you plug 0, 2, 0 into here, you're going to get -4, which just works. Okay, so part D, find A. How do you find A? So A is, it's the points A, -1, and 5. So A, -1, 5. So I believe we just got to plug it into this equation and solve for A. Nothing too tricky. So let's do that. It's going to be -4a and then minus 2y. So that's just going to be a plus 2. and then you plug 5 into minus 15 equals negative 4. So that means that's negative 4a is equal to, what's 15 plus, or what's 15 minus 4? It's 11. Okay, so it's 11, and then you have 2 over here, so it's actually going to be 9. Let's just make sure I did that right. So I add 15 on both sides, so I get 15 minus 4, which is 11, minus 2, which is 9, and then divide by 4, or negative 4. So therefore, a is negative 9 on 4. I'll take that as the answer. Okay, AB and AD are adjacent sides of a parallelogram. Find the area of this parallelogram. So AB and AD are adjacent sides of a parallelogram. Okay, find the area of this parallelogram. That's just going to be the norm of this normal vector. Right, because the length of the normal vector, the length of the cross product tells you the area spanned by those two, not the area, the area, yeah, the rectangle parallelogram area whatsoever. So we're just going to do the norm of negative 4, yeah, minus 4, negative 2, negative 3. So that's just going to be, let's see, there's a lot of numbers which I don't like. So that's just going to be the square root of 16, and then we have plus 4, and then we have plus 9. That's just going to be square root of 29, I think. Square root of 29. Hopefully that's right. Yeah, that's all for that question. So question 10, final 6 marks of the exam. And we have 14 minutes, 13 minutes to go. So let's try to do this. So the position vector of a particle is given by this over here. Write 5 minus 6t in the form... Ooh, okay. So now I have to remember my trig identities, which I don't know if I remember them too well. Let's see. I think the cosine identity, it was cosine of 2t is equal to 1 minus 2 times the sine squared of t. I think that was it. Right, so if I try to rearrange this now, I'm going to get the sine squared of t, and that's going to be equal to, 1/2 minus, or actually I'll write it as 1/2, and then 1 minus cosine of 2t. Right, so plugging this in over there, so 5 minus 6 sine squared t, what is that going to be? It's going to be 5 minus 6 sine squared t, we can rewrite as 1/2, and then 1 minus cosine of 2t. Yeah, simplifying this gives 5 minus 3, 1 minus cosine of 2t. Expanding it out gives us, well, this is negative 3, so it's going to be 2. And then we have a plus 3 cosine of 2t. Yep, that should be it. Cosine of 2t, and these are positive integers. Perfect. Show that the Cartesian equation of the path is this thing. Okay. So what can we do? I probably want to convert... Yeah, I'll convert this expression over here, the I component, into the form we had, and I'll use the double angle formula for sine. So here, this part we have under control. This part over here, we can write this as 3 times the sine of 2t. Right. Yeah, that should be it there. So let's write down the equation. So we have x first of all. That's the I component. So x is equal to, we have 2 plus 3 cosine of 2t. And then the y component is simply going to be 1 plus 3 times the sine of 2t. So we got the same amplitude over here, so we're going to get a circle, which, yep, is what we're expecting. So let's rearrange things over here. So x, we can rewrite this equation as x minus 2 over 3 is equal to the cosine of 2t. And then we can write this equation over here as y minus 1 over 3 is the sine of 2t. So squaring both of these and adding it together, we get x minus 2 over 3, but squared, plus y minus 1 over 3, but squared, is equal to 1. Okay, but we can rewrite this So implies, this means that x minus 2 squared plus y minus 1 but squared is equal to 9, because 3 squared is 9, and I bring the 9 over. Okay, that's straightforward. Part C, the particle is at point A when t equals 0, and at point B when t equals A, where A is a positive real constant. The distance traveled along the curve from A to B is 3/4 of a pi. Finds A. So we'll just set up an integral, the arc length integral, and yeah, finds A. Or alternatively, because this is just a circle, we can do it this way. So we know that the radius of the circle is 3. So the circle, where's the circle centered? It's centered at 2, 1. So this is the points 2, 1. The radius of the circle is this going to be 3. Now, where is this particle starting? It's starting at, yeah. It's starting at, well, if you plug in t equals 0, you're going to get, let's use these equations. So plug in t equals 0, you're going to get, am I writing these equations down correctly even? Yeah, I'm writing it down correctly, I think. So 1 plus 3 sine 2t. Yeah, if you plug in t equals 0, you're going to get 2 plus 3, which is 5. And then 1. So 5, 1 is the starting point. So where's 5, 1? 5, 1's right over here. That's the starting point. So, yeah. The distance traveled along the curve from A to B is 3/4 of an A. Find A. Well, you know the length is equal to, was it radius times theta? Right? So radius over here, so the length is 3 pi and 4. The radius is, what's the radius? The radius is 3. And then you have theta. So that means the angle that's traversed over here, the theta angle, is precisely equal to, what's that going to be? Just pi and 4. Now, because this t parameter is going at double speed, because it's like cosine of 2t, sine of 2t, we hit an angle of pi and 4 at exactly half of that. So exactly t equals pi and 8. Because when t equals pi and 8, we get pi and 4 inside of these sines and cosines, which corresponds to the angle that we get over here. So I'll go with t equals pi and 8. Hopefully that's the right answer. Oops, what's happening over here? So how many marks was that? That was 4 marks, so I got 2 marks left. And we got 7 minutes left. Hopefully we can do this. So find all values of t for which the position vector of the particle r of t is perpendicular to the velocity vector. What? Finds all values of t for which the position vector is perpendicular to its velocity vector. I was gonna say it's all values, but it's actually not, because this is not centered at 0. Okay, so what we need to do is we need to get the velocity of that thing somehow, and then just dot it with the position vector and set that equal to 0 and solve for t, which shouldn't be too bad to do. So, yeah. Let's try to write down the velocity. What I'm gonna do is, well, I'm gonna move this page over to here, just so it's easier to, look across instead of having to scroll diagonally and whatnot. So let's write down r of t, or r dot of t. So what's r dot of t going to be? R dot of t. So r dot is equal to, I'll write it in components, like in brackets without i's and j's, because I don't like i's and j's. How do you differentiate that? So we have this is the x component over here, or down here. So if you differentiate that, that's going to give you 6 times -6 sine of 2t. It's -6 sine of 2t. Okay, and then what's the y component? If you differentiate that, that's going to give, well, the 1's going to disappear, and it's going to give 3 times 2, which is 6. So 6 cosine of 2t. 6 cosine of 2t. Okay, let's also write down r as well. So what's r? R is precisely, I'm basically just copying it down again. So 2 plus 3 cosine of 2t. And then we have comma 1 plus 3 sine of 2t. Okay, and what I'll do is I'll just dot these two guys together and set it equal to 0 because it's perpendicular. The position vector, yeah, perpendicular to the velocity. So yeah, let's go for r dot our dot over here. And what's that going to be? Well, we'll multiply this and add it together. That's probably going to give us a bit of a mess though. So what I'm going to do is, yeah, let's just do it. So we have -6. Also, we can probably factor out a 6 out of this, I just realized as well. So 6, and then we can write it as sine of 2t. And then we have comma, cosine of 2t. And there's a negative here. All right, so we can factor the 6 out. So the 6 is going to come in front of the dot product. And we can just take this guy, so underline it in red. So red multiplied by this guy. And then we'll do the yellow multiplied by the corresponding yellow. Okay, so let's see what that gives us. We get -2 sine of 2t, and then -3 cosine of 2t, sine of 2t. So maybe we can use sine double angle later. And then a comma, we take the yellow and we multiply it together and we add it. So we have a plus. And then we're going to get cosine of 2t plus 3 cosine of 2t, and then sine of 2t. Right, so if we set this equal to 0, we can ignore the 6 there. So therefore, we have, let's clean things up a little bit over here. So we have -2 sine of 2t. So 0 is equal to this guy plus the cosine of 2t. And then minus, we'll write this as 3/2. I don't know if this is a good idea or not, but I'll do it anyways. So sine of 40, right? And yeah, we also have plus 3 on 2. We have the sine of 40 as well. And we want to solve this equation for t somehow, which I'm not too sure how on earth to do. Because this looks like an absolute mess here. But what I can probably do, we can probably combine these together and see if that helps. So this is -2 sine of 2t, and then plus the cosine of 2t. And wait, those cancel. What, do they cancel? I think they do. Do they? Wait, surely not. So this came from, let's see. So we have sine times, yeah, negative sine times 3 cosine of 2t. That gave us this part over here. And then for the other part, we had a cosine times 3 sine. So they do cancel, which is really, really quite nice. So cancel, cancel. And we're left with a 0 over here, so we can just solve this, and this turns into some trig equation with a tangent or the cotangent or something. So we have 2 times the sine of 2t, and this is equal to the cosine of 2t. Okay, so we have tangent of 2t is equal to 1/2. Is there a restriction on t? So t goes from, t is greater than 0. Right, so we want to find all values of t for which this occurs. So that's a bit funny. T is equal to 1/2. I probably did something wrong though. I don't know. Let me check my working again. So we have r of t, and 6 is gone. So we have, yes, so we have sine of 2t, -2 sine 2t, and then we have plus a cosine of 2t. That should be it there. Maybe I'll have to write in terms of arctangents. Who knows? So if you take a look at the tangent, so here's the unit circle, and we want a gradient of 1/2, pretty much. Here's a gradient of 1/2. So what's this position over here? That's 2t is equal to inverse tangent of 1/2, right? So t is just going to be 1/2 inverse tangent of 1/2. Okay, but 2t is equal to this thing over here. But we can also get other solutions if we just simply add pi times k. Right, because you get the solution, you get a gradient of 1/2 every time you rotate pi around. So therefore, t is equal to 1/2 tan inverse of 1/2, and then plus pi over 2 times k. And with that, we are done. And k is greater than, k is a positive integer as well, because t can only be positive. And we're at 59 minutes and 45 seconds on the recording. So pretty much, yeah, we're pretty much out of time. So if I did this exam, I'd probably finish like right on time pretty much. So final thoughts on this exam. It's nothing too special, I think. I was a bit rusty. I think I felt really slow on this exam. Right, I had to pause a lot and think about stuff. I'd probably do this a lot faster if I actually tutored Spesh and had things fresh in my head instead of having to think about things all the time. But yeah, hopefully I got most of this right. I'll add annotations and whatnot, or comments below in the video if I got anything wrong. But yeah, that's all for today. Induction question was interesting though. I enjoyed it, but a lot of people probably didn't. And everything else was pretty standard. I don't think there was anything too special with this exam. So VCAA went pretty easy this year, I think. But yeah, those are all my thoughts on this exam. Hopefully you guys enjoyed and found it useful. And yeah, up until the next one, have a wonderful day. Good luck on the rest of your exams, and I'll see you in the next video. Bye bye.